So, okay, let's continue. So first, hi, my name is Gabriel Mesquita, and to begin this presentation, I'm going to talk a little about myself, what I'm doing right now. I'm from Brasília, and I came to São Paulo 2 months ago to work at Creditas, so I'm a software developer there. At the moment, I'm working with Ruby on Rails, but throughout my career, I've worked with Java, React, React Native, Ember. And if you want to get in touch with me, send a message, ask some question, you can find me at LinkedIn. Just search for Gabriel Mesquita and you can find me there. So about the presentation, I'm going to start with some motivation, and after that, I'm going to talk a little about the theory that is necessary to understand the methodology behind the project. After, I'm going to talk about my results and finish with my conclusions. So, about the motivation. The question that I want to answer here at the end of this point is, why did I start this project after all? So the scenario was, I was at Brasília at a campus party, and I was watching a presentation from a group of developers from the Chamber of Deputies. And they were talking about some machine learning and data science project that they were doing back there. And throughout their presentation, they mentioned the CEAP. And when they talked about that, and again, I'm going to explain better what it is, what it means. I went to research a little about the regulations behind CEAP. And when I was doing that research, I found a problem situation. And the situation was basically the fact that CEAP is a monthly quota. So CEAP stands for quota for the exercise of parliamentary activity. So it's basically some money that the deputies have to spend with their work. So, for example, let's say that they need to buy an air conditioner for his office, or let's say that he needs to go back to his state to some reunion, or anything related to his work, he can use the CEAP money to ask for a refund. So that's what CEAP means, and it's a monthly quota. Every month, every deputy in the Chamber of Deputies has some amount of money to spend with his work, his or her work. And as I said, I was researching to find if we had some kind of regulation to this money, because it's public money. We help, with our taxes, we give money to them so we can, do their work. And there is a regulation to this money. So basically, the deputies, they cannot spend this money with companies or services that they are the partner or a relative until the third degree of the deputy is a partner of the company. So let's say that some deputy wants to buy an air conditioner and he's a partner of the company. He cannot do that. That's illegal. And likewise, if his wife is the partner of the company that he is consuming a service or buying a product, that's illegal. And that was the problem situation that I have found in my research, because I wanted to know if the Chamber of Deputies, they done some regulation in that monthly quota. So after my research, I proposed a solution. I forgot to say, but this was my graduation project. So I was basically looking for anything to do to finish my graduation. And so with that problem, I proposed a solution to my teacher. And the solution was basically get the CEAP open data and the TSE open data. And with that data in my possession, I proposed to create a web system with useful information regarding CEAP transactions and donations for 2014 campaigns. This is going to be more clearer later, but this was basically the solution. And to perform these queries and give some information, I was going to use the NoSQL database or IntDB, and I chose to use a graph database because the problem that I was dealing with was a problem of relationships. I wanted to know if some deputy executed a transaction with a company, and if this deputy relates to some person until the third degree, so I can have self relationships, and if this person relates to the same company, so it's basically a problem of relationships. And graphs are a great structure to work with that. So that was basically the solution. So now that was the motivation. I started this project because it was my graduation project, so I had to do, but I also wanted to do something meaningful, something that I could add something to society and, of course, to my career as a developer and a computer scientist. So about the theory now. I'm going to talk a little about the important concepts that it is necessary to understand the methodology that I have done in this project. So first, what is a graph? We need to understand a graph to understand how a graph database works. So a graph is basically a data structure. And in an informal way, it's a set of vertices, edges, and a function that associates each edge with a pair of vertices. I'm going to show some pictures, and it's going to be clear what a graph is if some of you don't know what it is. And the graph structure, they have some properties. So you can have loop inside the graph. You can have oriented graphs and graph that is not oriented. You can execute some algorithms such like shortest path, and you can have attributes in both your vertex and edges. So this is a graph. In here we have two examples of graph. This one is an oriented graph. You can see that the edges, you can see that it starts here and it ends here. But in this way, you don't have some kind of orientation. You don't know where it starts and where it ends. So it's one of the properties that a graph has. In OrientDB, which is the database that I use here, the database works with oriented graphs. And it is important to be oriented, so you can know where it starts and where it ends, the edge in this case. But you also have some other properties, as I said. You can have a loop. You can have an edge that starts and ends in the same vertex. And you can also have attributes in your vertex and in your edge. So you can, for example, create a vertex that represents a deputy. And it can have the attributes name, age, political group, whatever. And you can also have attributes in your edge. For example, what is the relationship between this vertex and this vertex? You can name this relationship. And you can also add attributes, such like a date, for example. You can say that this relationship is valid between, some date, and it can no longer be true in, some other date. So you can have attributes in both vertex and edges. Now, following, we need to understand what a NoSQL DBMS is. So NoSQL stands for not only SQL, and DBMS stands for Database Management System. So a NoSQL DBMS is a database management system that not necessarily works with SQL. It's basically a group of databases, and they have some specific characteristics. For example, a NoSQL DBMS usually works with a concurrency model more flexible than ACID. So relational databases such like PostgreSQL and MySQL, they work with the concurrency model ACID. And usually NoSQL DBMS works with some other concurrency model, for example, Bayes. But this is not a rule. You don't have to, okay, I'm a NoSQL database, so I have to use Bayes for my concurrency model. This is not true. For example, OrientDB is a NoSQL DBMS, and it works with ACID concurrency model. So it's just a set of characteristics that they have, but it's not a rule. You don't have to follow them, straightforward. And also, they tend to worry about availability and consistency of data because they work with distributed databases. So they was kind of born to solve different problems than relational database was born to solve. So it's a category of databases to solve different problems and have different characteristics. So it's basically that. So here we have some examples of NoSQL DBMSs. We have Google Bigtable, we have DynamoDB, OrientDB, Neo4j, and inside this group of databases, we have different kind of NoSQL DBMSs. For example, OrientDB and Neo4j, they are graph-oriented. Bigtable, for example, is column-oriented. And DynamoDB, they work with key-value pairs. So they are different because they work with different structures to store your data. So in OrientDB and Neo4j, you store your data in a graph. In Bigtable, you store in a column-oriented structure. So these are some examples of NoSQL DBMSs. Now, let's talk about graph-oriented DBMS, which is the structure that I use to solve the solution that I talked back there. So as I said, they store your data in a graph structure. And they have some specific characteristics that is not present in some other DBMSs. One of them is the index-free adjacency. So these characteristics allow a graph-oriented database to perform traversal in your graph with efficiency. That's because you don't work with join operations inside a graph-oriented database. And this happens because the objects relate to each other through pointers. So you don't have to perform joins to look for relationships inside your database. And the usage of graph-oriented databases are, we have a lot of use. For example, we can use in social networks like Facebook, LinkedIn, Twitter. We can also work with bioinformatics, recommendation software. And the focus here, when you talk about graph-oriented database, is with relationships, as I said earlier. So if you find yourself working with a relational database and your queries starting to get a little complex, and you feel like it's not natural, so maybe it's not a role, but maybe you are you're working with data with complex relationships, and graph databases are a good use to that kind of problem, because graph exposes relationships naturally. This is going to be clearer when I show you a picture of a graph. I know this is a lot of information, but when I show the graph, and I'm going to explain more why the relationships are naturally exposed in a graph. This is the face of OrientDB GUI. So here we have a graph, and it is oriented. You cannot see the orientation here because it's not such a good photo, but we can see here that we can perform queries in the GUI, and it returns the resulted graph. As you can see, we have here a vertex. We have a lot of edges, and we can see that this vertex relates to this one through this set of vertices, and the edges, they explain the relationship between this relationship. This is not a graph that I use in my work, and later I'm going to explain more about the relationships inside the edges and how everything works. But this is the face of OrientDB GUI. Now about OrientDB, it is an open source DBMS under Apache license, and an interesting fact is that OrientDB is a multi-model DBMS. So it works with document, key value, and graphs. So inside one database, you can work with 3 kinds of data structures. You can store your data as a document, as a key value pair, and as a graph. And this is really good because you have flexibility. You can work with graphs when you have complex relationships inside your data. You can work with key value if it makes sense to your problem. So it gives you a lot of flexibility. And OrientDB is written in Java, and that's important because it has a good interface with Java, of course. And my ETL software was written in Java because OrientDB is written in Java, and it's good to interface with. OrientDB has a lot of other characteristics. So as I said, NoSQL has it's a group of databases, and usually NoSQL databases, they have a flexibility to define your schema. So if you're working with a relational database, you have to define your schema, and OrientDB gives you that flexibility. And the most important point here is that the query language in OrientDB is based on SQL. So it is really natural to get out of the relational world and come to work with OrientDB because the query language is derived from SQL. And this makes very easy to go and start to work with OrientDB. As I said before, we don't work with join operations because of the pointers. And one good feature here is that OrientDB in its community version supports distributed architecture, and U4J doesn't. So it is a good thing to work with big data and big amounts of data. Another important feature of OrientDB is that it works with object orientation. So you can define classes inside your database, and you can specify if a vertex belongs to a class, and you can also define inheritance. So you can create, for example, an employee class, and you can create a regular employee and contract employee, and they are children classes from the employee class. And this way you can organize your data to perform better queries and look for better performance inside your database, working with object orientation. To finish the theory part, I wanted to talk a little about REST, because as I said, I'm developing a web system, so I need to communicate with my database. And OrientDB gives a REST interface so you can communicate with the Dbms. And REST is basically a set of architectural restrictions. So Roy Fielding, when he created the REST architectural restrictions, he wanted to give your system to be general of interfaces and emphasize the scalability of interactions between your components. So he created these rules so you can create a scalable system. And one fact that born of this is because, okay, there are rules, but you don't have to follow them 100%. You can follow just a bunch of these rules, and you start you are called, your system is called accidentally RESTful because you do not follow 100% of the rules of REST. So an example here, if you want to connect your system or whatever with the OrientDB, you just have to execute a GET action and specify the server, the port, and the name of the database. And after that, you specify your email or your user account, your password, and you are connected to the database. So this is important because I wanted to communicate my system with the database. So, and OrientDB works with a REST interface. So it's important to understand what REST means. Now, about the methodology. I basically want to explain how I've managed to start from zero and get to my results in this point. So that was my objective. I wanted to find if some company donated money to the deputy in his campaign in 2014. And I also wanted to know if the deputy in 2017 used the SEAP money with the same company. I wanted to merge these two information to find that relationship. As I said, that's the importance of the relationship inside a graph. And I also wanted to detect frauds in SEAP transactions. So I wanted to find if some deputy spent money with a company and he's a partner of that company, or a relative of the deputy is a partner of that company. So that was my objective in this project. So to begin the implementation, I had to retrieve the data. So both the SEAP and donation data set, they are open. And that's really important because if they were not open, I would not be able to start this project at all. So that's a good point. But I wanted to point out the challenge that it is to work with open data in Brazil today, because they do not follow some common rules. So each government company, let's say like that, they work with a different kind of data set. So one of the data sets specifies the deputy CPS, and the other doesn't. So I had trouble to merge these two data sets together because I didn't have an unique number identifier. I had to do that with his name. And again, the name in one data set was like his nickname, and in the other one was his correct name. So I had trouble to do this merge because they do not follow some common rules. So today we still have some challenge to work with open data in Brazil because of that point. But in the end, it all worked it out. So after I retrieved the open data, I had to build my data model. And this is an important point because the data model is created to give an overview about the data organization, how it is organized inside the database. And it also shows its properties and relationships. So, and I follow this model, this data model here. It's called Graphed. So this was my data model. I'm going to explain a little bit why I made like this. So let's start. Here we can see that I have a deputy, let's say vertex, and a deputy can execute a transaction, and some transaction can be supplied by a company. Okay, this path here is the SEAP, the SEAP data set gives to me. Now, a company can also execute some transactions, and this transaction can be donated to a deputy. This path right here, it's the TSC 2014 donations to the deputies campaigns. So with this, I was creating the data model like this, I was able to find if some deputy gave money to a company and if a company donated money in 2014 to the deputy. But I wanted to say that this is not illegal. It is not illegal to do that. But I think that it is an useful information if you are searching for some deputy to vote on. So I think it was a good information, and I wanted to add in my project. And now in the other part, it's the fraud patterns that I wanted to find. So if a deputy executes a transaction that is supplied by a company, and at the same time the deputy is a partner of this company, we have a fraud pattern. And that's why the data model is good, because it shows how the vertex relate to each other and its properties. So I can see that a deputy has a name, has a group party that he belongs with. I can see that the company has some identifier and a name. So that's why the data model is really important. And also, if a deputy relates to some person until the third degree, so we can see that we have some self-relationships here in the person vertex. And if this person is a partner of the same company, we also have a fraud pattern. So that was my data model. So after retrieving the data, building my data model, I had to load this information inside the database. So I built a software. We call that kind of software an ETL because it stands for extract, transform, and load. So I basically extracted the information from both CSV files, from the SEAP file of 2017 and TSC donations file of 2014. And after I extracted the information, I started to transform the data so it could be correct and it means something. So I removed, for example, some state deputies because I was working with federal deputies, and I created some objects that it meant something to my domain. For example, I created a deputy, company, and transaction objects. So after I done this transformation, created those objects, I started loading those created objects to my database. This whole process took 16 hours to load the SEAP file. The SEAP file is a little bit bigger, and to load only the donations from the TSC file, the TSC dataset, it took about 5 hours to load everything with a computer with this configuration. Now, about the workflow. we have some interesting points here. The workflow works basically like that. I read line by line from my data set, from my file, and I check if a deputy, it is already persisted, because if it is already persisted, I don't have to create it again. I just need one vertex to represent one deputy. And after I check this, I create a vertex. I create a vertex, or I retrieve the vertex reference. So if the deputy is created, I just retrieve its reference and create a transaction and create the relationship between them. So for example, I'm reading the line of a deputy for the first time. So I create the deputy vertex, I create a transaction, and I relate these two vertices with each other. And that's basically the process of the whole ETL software. It basically does that. So now for the fun part, about the queries and my results. So as I said before, OrientDB query language is derived from SQL. So it's pretty straightforward to read when you're not working with graphs. But when you're working with a graph, it adds some new functionalities. For example, the match function. So if you want to find a pattern inside your graph, you have to use the match function. And then you pass a block that you specifies the pattern that you're looking for. So in this query, I'm basically looking for a deputy that executes a transaction with a company. And we have a comma here. It stands for the AND operator. This same company that I have defined here executes a second transaction. Is not the same transaction here. We have T and we have T2. And this company that executed a transaction, it's donated to the deputy. So that's the pattern that I'm looking inside my graph. And that was the result that I was able to find. So this worked with open data. It was not manufactured data that I have to do inside my database. And that's the graph that I was able to find. Now, the other picture was not good to understand the relationship, so this one is better. We can see here that we have a company. This is the light brown vertex, and the company executed a transaction that was donated to my deputy. And at the same time, the deputy executed some 3 transactions that was paid to the same company. And that was exactly the pattern that I was looking for. Again, this is not illegal, but it is a useful information. This pattern was found for 7 deputies, all of them in Minas Gerais. As I said before, I had troubles to merge these 2 information. So it was like a workaround. I have to do only to Minas Gerais and Distrito Federal deputies, because it was a lot of deputy names that I had to fix, and I didn't have much time to work with the whole data set. So I had to do only with Minas Gerais and Distrito Federal deputies. With this query, I was able to find 44 transactions registered in CEAP dataset and 96 donations registered in TSC files. And again, remember that the data model was really important, so I could execute the query and find the patterns as I wanted. Now, this pattern, for example, it's a fraud pattern. So again, we use the match function to find a pattern where the deputy executes a transaction that is given by a company, and the deputy is related to a person, and this person is related to the company as a partner. This is a fraud pattern. This is what I wanted to find in my project, but I found an issue during the implementation because relative information from the deputies, they are not open. I cannot find what's the wife of some deputy, or what's the name of his brother, his CPF. I cannot find that, and it was a little frustrating because I executed a lot of the process to get in this block problem, but as a workaround, I implemented with fake data. So I was not actually able to find fraud in CEAP because the relative information, they are not open. But with my data model, with the whole process, if the Chamber of Deputies wanted to find some fraud in this data, they could do that with this whole process that I'm explaining to you guys. Okay, now for some other results. So as I said, I faced some problems and it was a little frustrating, but I came with an idea to create a collaborative system. So this collaborative system would allow society to give useful information so we ourselves could find these fraud patterns on our own. So the collaborative system has some objectives, which was show useful information about the deputies' transactions in CEAP and the donations for their campaigns, which was the result that I showed before. But it also allows users to collaborate with information that it is not public, such as the deputies' relatives information. And with that, we can maybe or maybe not, it depends if the deputy has done something wrong or it didn't, find some frauds in the CEAP data set. The collaborative system was written with Ruby on Rails. That was the amount of deputies, companies, and transactions that I had in my database, and the system was showing these informations to the user. And that was the face of the system. I am not a designer, so I just use Materialize to, it's more like an MVP. I didn't want it to do, something really pretty. I just wanted to, make it work at first. So this was the collaborative system phase. Now, for some useful information. Check here, please. So, okay, the useful information. As I said before, once again, the OrientDB query language is derived from SQL. So if you read this, you're basically reading a SQL query. It's, identical. I'm selecting from the deputies. I'm selecting his group party. I'm counting them, and I'm grouping by the political group. And with that, I can find the distribution from the political groups which use the CEAP the most. So we can see here that PT, we cannot see because of this, but PT, PMDB, and PP were the political groups with the deputies that use CEAP the most. I think that we can assume that it's because we have more deputies from these political groups inside the Chamber of Deputies. It may not be that, but I think we can assume that. But also, it is a use for information. I cannot pass this because I think I cannot pass my slides because of this. The focus is in here. Guys, I need some help. Thank you. Okay, so I have some technical problems here, as you guys can see. You just need to, click on OK, and I think I can go on. Yay! Thanks. Okay, it works. So now, moving on, because I only have 5 more minutes. Next, I wanted to find, I found the political groups that most use CEAP. Now I wanted to find the deputies that most use CEAP money. So here, again, I'm working with basically a SQL query because it's not actually working with a graph structures. It's only information that I'm gathering. And with that query, I was able to find those deputies, and they were the deputies that most use CEAP money in 2017. I've done with the 2017 dataset because I started doing this in 2017, and the 2018 dataset is not done yet because we're not in 2019. So yeah, that was the results, and these charts they were appearing in the web system. If you click on a link, it was going to show you a screen with those charts and those informations. Now moving on, I wanted to also find the companies that most work for SEAP, and with that query, I was able to find that the deputies, they travel a lot. You can see that the 5 top companies, they are traveling companies. And I also found out, it's not showing here, but they use a lot of Uber to travel inside the city. So those were information that I wanted to give to society, so they can know what company is giving services to the deputies, what deputies uses your money to use those services and those products. Okay, I only have 3 minutes. I don't think that we're going to be able to see the other slides, but they were basically showing the graph that okay, maybe we can, maybe we don't. Okay, I wanted to, I was working with graphs, but I was only able to see in the OrientDB GUI. I wanted the population to see that. I wanted to show people if some deputy was doing some fraud pattern with your money, and I didn't want to use a table to show that information. I wanted to show a graph in the web system, and I was able to show it. The fun fact, it was really ugly, because again, I'm not a designer, and I used a JavaScript library to do that. And this is one of the conclusions that I wanted to do. It was the fact that we can use graphs to expose information, expose knowledge. We can, stop thinking only in tables and relational databases, and we can start working with new ways to show information and show knowledge. And as I said, it was an MVP, so it was really ugly. You guys can see. If you guys can fix there, I think we still have time. I have 2 minutes. And that was basically the end of the presentation. I was showing the graph in the web system, and the whole process was concluded. I get the data, I executed some ETL software, load my database, and show information in the web system with graphs, with charts. And my idea was to upload all of this in production and start from zero. And so the graph was going to be empty because I didn't have any information about the deputies' relatives. And as long as the population and everyone was collaborating with new information and the deputies' relatives' information, maybe or maybe not, we could find some frauds in real time, because the information was going to be inserted in the database, the queries were going to be executed, and if some fraud pattern was found, it was going to appear in the web system. Yeah, that was my conclusion. Thank you all for listening to me.